The Indian Railways are the lifeline of the nation, carrying passengers and goods on the largest network in the world. India is a geographically diverse country with lofty mountains, deep valleys, extensive plains, wide plains, and a number of islands. And yet, the subcontinent is extensively interlinked through the railways that often crisscross through difficult terrain such as rivers, valleys, and mountains. A large proportion of railway bridges in India are steel bridges. Of those, the bridges of the 19th and the early 20th centuries are made of an early kind of steel containing more phosphorus and sulfur that makes them brittle in nature and so less reliable. Trains must ply, however, with a guarantee of safety and efficiency to millions of passengers every day. In order to maintain that promise, the Railway Board made a policy decision to replace early steel bridge girders on the railway system. Looking at the diversity in the kinds of bridges in this country, the task demanded a great deal of responsibility and innovation. Regirdering of the Airgaon Viaduct in the Kasara Ghat of the Sahyadri Ranges is a case in point. The Airgaon Viaduct lies on the down main line in the Kasara-Igatpuri NE Ghat section in the Mumbai division of the Central Railway, the erstwhile traffic 27 trains daily on an average. Faced by challenges like rugged terrain and limited space, replacement of 43.5-meter underslung girders on this bridge was definitely a difficult, labor-intensive and precision-based task.
This is a very challenging job for the railways. This bridge was constructed about 100 years, more than 100 years back, and needs replacement. On Indian Railway, we have planned to replace all the early steel girders. These early steel girders are more than 100 years old. So it was not safe to run the trains on this type of girders. On Central Railway, this is the last girder which is being changed. We have completed all the works of bridge which was overdue.
The engineers decided on steel girders for their lighter weight over PSC girders, thereby avoiding the strengthening of the substructure and the foundation. And since the trusses of the existing girders were 3.9 meters apart, a narrower new girder could be launched to fit within the existing trusses, thus paving the way for retaining the existing architecture, which was the most appropriate for the terrain as it blended with nature beautifully. To reduce horizontal loads, the pendulum bearings that had helped distribute longitudinal forces onto abutments and piers had to be replaced. The solution was found in pot PTFE-free bearings, where the entire longitudinal forces would be transferred to the lower abutment 1. These bearings also had the added advantage of requiring little maintenance. Since all the longitudinal forces had to be transferred to abutment 1, the girders had to be interconnected. These were basically pinned connections, which had to be designed to transfer only the longitudinal forces with the help of an extended arm of the girder connected with the trestle on the abutment. Cross beams were fixed in between the sleepers at 8 points on the top chord of the newly launched girder, and the old trusses were hung on these cross beams with the help of wire ropes. Following that, The truss members were dismantled one by one in a predefined sequence so as to prevent sudden collapse of the trusses. The contract for the Airgaon Viaduct regirdering was awarded to Pilcon Engineering of Nagpur on the 3rd of July 2008 with a target date of completing the girder replacement job by the 30th of May 2009.
200 से ज़्यादा लेबर स्किल्ड अनस्किल्ड आदमी हमारे साइट पे हैं और ये जो दूसरे गर्डर की अभी रिगर्डरिंग हुई है इसको 60 आवर्स के ब्लॉक में प्लान किया गया था, लेकिन 55 आवर्स के अंदर में ये ब्लॉक कंप्लीट हो जाएगा। मेनली इसके पीछे रीज़न जो है हमारी टीम, हमारे आदमियों ने राउंड द क्लॉक काम किया है। कल सुबह 6 बजे से लेकर अभी तक के जो है लगातार काम कर रहे हैं और जो भी साइट के ऊपर में मशीनरीज टूल्स प्लांट की रिक्वायरमेंट थी वो सारी अप टू डेट है।
The fabrication of the new girder was done in-house by Central Railway at their Manmad workshop. It was a step-by-step process, in a way establishing the format and tempo for the entire job. Once the drawings for manufacturing feasibility were verified, 2 scale-sized templates were prepared to fabricate the first members of the girder. Jigs and master preparation followed. Now the actual fabrication of the members began.
Tunnels, there is no site, there is no road approach. Every material has to be transported through rail, taking traffic and power blocks, which made the
The Airgaon Viaduct girder replacement job began with the construction of the site office, girder assembly yard and the carrier and gantry fabrication yard. Next, necessary equipment. The site. The members of the underslung girder that were assembled here were transported from the Kasara yard on BFRs. The girder finally began to take shape as it was assembled here under challenging conditions. Field riveting involved 18,000 rivets per span. All these rivets that are intended to hold the structure for decades to come were supplied by the Manmad workshop. Everything was in-house at Central Railway on this job to ensure the best quality. The assembled girder was pre-lifted to a height above the BFR height. During the block, cross beams were placed on top and across the BFR on which the girders were side slewed and positioned directly over the BFRs entirely by teams of men working in unison on pulleys, chanting as they went along. After correct positioning, the cross beams were released and the girder was supported at all bottom nodal points on the BFR and fully secured so that it didn't slide or topple during movement on the upgrade. The gantries were specially designed to take the girder load, with the main concern being prevention of failure in buckling. Since the gantries were 10.6 and 11.9 meters high, these had to be strong enough to take the girder load and also eccentric loads if any, and yet be light enough to be transported to the required location. The gantries were pre-tested for the girder load on the assembly platform. Carriers of two sizes were fabricated, one each for the two gantries to transport these gantries from the yard to the abutment and pier locations. With the gantries in position and the girder firmly in place, the girder special was ready to move into the final position. It was a small distance from abutment 1 to the gantries, but a precarious task getting there. The girder was eased into position. The pulley blocks were fixed to haul up 160 tons of steel by sheer manpower. A total of 12 pulleys were deployed for the job, 10 for actual operation, while 2 as standby. These 10 pulleys were distributed as 5 each on the 2 gantries. The pulleys that were used were of rated capacity of 20 tons each and were tested in the laboratory for 1.5 times the rated capacity and later at site for the girder load. Familiar sights and sounds resounded again. Slowly but steadily, the girder was raised enough for the BFRs to pass. Work was on schedule. The track underneath and the floor system was dismantled, making way for lowering of the new girder. The girder lowering took place in the sweltering hours of the afternoon the next day. This scheme required the least block hours and least energy as the girder would be lowered by the force of gravity. In addition, assembly of the girders was at a safer location with better control on various operations, including that on riveting. It took great effort to maintain the girder in a horizontal position during the last phase of lowering it onto the new pot PTFE bearings, which was extremely important for the uniform loading of the gantries. The entire job was a precision-based task made possible by mind and body synchronicity. Finally, the girder was properly seated with bearing positions and the girder matching perfectly. Despite everything, the job went on like clockwork.
We are standing about 180 feet above the ground level, and to think of a scheme which was viable and which was also at the same time economical was a great job. The trusses of the old girders are about 3.8 meters apart. The new girder is about 2.1 meter apart only. So we could conveniently place it inside with very little margin on both the sides. So it was a very precision work. And then because we are on about 180 feet above the ground level, so we had to see that everything goes safe. Passion, great idea, planning, and of course the hard work and dedication at the time of execution. That has carried us so far.
It's a wonder what can be accomplished despite the odds when engineers put their minds to it. The Airgaon Viaduct girder replacement job signifies Indian Railways' engineering proficiency. The people on this job worked round the clock to complete the girder replacement within the stipulated block.
A proud moment for the entire team, and this has been possible because of the support of all our senior officers, our Chief Bridge Engineer, the Principal Chief Engineer, the General Manager Central Railway, and the hard work and dedication of all the staff down below, the Executive Engineer, the Assistant Engineer, and the Bridge Engineers, the Bridge Inspectors, and all the Group D staff that are available over here.
The complete work of making a site where the girders could be placed and the launching of girders was therefore undertaken under extremely difficult site conditions. I am very happy to see that the complete work of the launching of the girders has been completed on the 21st of May 2009, much before the onset of the monsoon.
So, the next time you are traveling in a train, passing over a steel bridge, you know how it got that safe.